All right, welcome to the Future-Proof Your Asset Performance Management webinar. We'll get started here in a few minutes as some folks continue to file in. I'm David Rogers. I lead our industry solutions for manufacturing, energy, and transportation. And we have a jam-packed agenda here today, covering a quick intro to some of the things we're seeing across our customer base, ways they are using data and AI to further their asset performance management. We'll go into a demo for a generative AI application that is built on the Databricks platform. And then we will show you a solution accelerator so you can get started directly within your environment. So as we begin here, I'd like to start off with a customer use case here that's I saw it recently as I was preparing for this webinar. In the Wall Street Journal, there was a story about a lithography machine, and it really went into detail of what's going on with assets that need to be serviced to maintain their performance for their customers. So you have engineers all across the world maintaining assets. It can be an energy asset, it can be a semiconductor machine, it can be machinery within an automotive factory. You're trying to figure out what is going on with the health of that asset and know how to diagnose it, fix it, repair it. But there's a lot that goes into machinery nowadays. It's very complex, as the Wall Street Journal put it, unfathomably complex, right? There's a lot of things that, as you have a workforce, you're trying to make sure they're, experts, and you want to upskill them as fast as possible to be as productive as possible for your customers and make sure that your machinery is operating at full performance. And that's what your clients are expecting. So whether you sell machinery, you service machinery, you are have a new type of business model where you're selling equipment as a service or uptime as a service, clients expect their machinery to work day and night, but you never know how a disruption is going to occur. I think this past week, there was an earthquake in Taiwan. So there was disruptions to their fabs there. I hope everyone is safe and secure, but that equipment is super sensitive to things that are going on that are, you can't control. So you want to be able to bring that equipment back online, bring that fab and get it back to producing as quickly as possible. But there can be things that you can't even, you may not even be able to think about or conceive of. There's another great example mentioned about a shift in wind patterns that had an excess set of methane, right? And dairy farms, right? There's cows, there's, cow farts, as they put it in the article. These things, you have sensors in your facilities and your machinery. It's able to sense these type of things that are going on, but it's really hard to understand how to relate what's happening in the environmental conditions or within the machinery itself and how that relates to the performance of the machine. But that's where data and AI can help bring that picture together. So an operator, a field service engineer, customer support engineer can really make an impact faster, bring that asset back online. And that's exactly what we're seeing across our customer base, where they're monetizing connected product data to create better value creation for their product portfolio and within their clients. Because they're able to have higher uptime, they're able to provide service, better profit margins on services. That gives them higher profitability. You're not just having a one-time sale of the equipment. You're actually extending that value that you get out of that equipment that you're selling through its decades-long life cycle. And so that incremental annual recurring revenue from connected services is something our clients are seeing as they are monetizing their sensor data and bringing that together in order for their clients to operationalize the equipment to produce the intended effects of that equipment. And this is where we bring in across the Databricks product, and we'll show this in the demo today, bringing in flexible, cost-efficient streaming data. You can process that data in batches or real time. You'll be able to tune that to your performance as you need for your workloads. And so you're getting the best price performance for that type of data streaming and batch streaming. you're able to govern the data. So we're going to talk a lot about governance today across not only the data and AI assets, but your generative AI, your agents that are emerging here that are taking actions on your behalf. You want to make sure that you're understanding how your generative AI is performing, why it's performing. We're dealing with heavy equipment and machinery. There's safety concerns. We want to make sure the model is grounded. We want to understand it's giving the right outputs. We want to know how that's occurring. And then if you want to bring in other types of alerting, data warehousing, external third-party data, you can bring that in as well. And then you'll want to power a real-time application. So we're going to spend a lot of time on the real-time application today. And that's really around bringing what we have as Databricks apps as a new way of bringing data and AI products quicker, both internal use cases as well as external facing applications. And that's really what we're all about, is powering all of these use cases across the data and AI stack. So we're really going to showcase all of these capabilities. And as we go through it, I really want you to think about your business. I mentioned a semiconductor use case at the top of the presentation here. But if you're in aerospace and you run an MRO operation, and maybe you're an engine manufacturer, turbine manufacturer, you're maintaining uptime as a service. That's what you're selling to your customers. The way you operationalize that business model is you are taking in the data inputs after every single flight, you're understanding the performance of that engine, and you're taking an action to make sure that is performing exactly the way it's intended, so an airline can get passengers safely from their origin to their destination. If you're over in energy, and we'll take a look at an energy use case here today, and you're looking at wind turbine performance, you may have a power purchase agreement with a utility. You need to make sure that that asset is performing exactly the way it is to your contractual agreement. So you want to use the data and AI. We'll walk through this to make sure you can service the asset. You're bringing that asset back online as quickly as possible when it's safe to do so. But then across your business, you're not just going to have field service use cases. You'll also have things in after sales with after sales parts. You'll want to understand what parts broke. Bring that in. You'll want to understand engineering and design, the impacts of performance on the actual design of the machinery, quality issues. The connected, if it's a consumer facing, connected product in terms of consumer preferences and personalization. All of these different things, it all comes from this product telemetry data that we're going to focus on here today. And you'll want to bring that together with your other data sources, your ERP systems, your maintenance management systems. Bring that together to drive your outcomes across field service and many other modalities for value. And then this really accomplishes that biggest challenge that I mentioned off the top. Manufacturing has an aging workforce that we all know about. We want to increase productivity. We want to increase competitive advantage of the equipment that we're bringing. But that all comes from this very specific domain knowledge. Manufacturing, you have the intersection of electrical engineering, mechanical engineering, machine learning, AI, right? All of these things come together. And you'll want to be able to, bring your workforce to have the skills. And maybe they don't even need to know that it's AI powered, but they want to be able to, have that understanding of how the equipment works, how to repair it, so they can be productive sooner. And that's especially valuable in field service. There's so much to learn. You only learn by walking the floor, going out to the asset, repairing things. You learn kind of the hard way, right? It's hard to disseminate this knowledge with some of these emerging generative AI applications. And we're going to talk through a RAG application, a retrieval augmented generation, that can help to bring in this corpus of knowledge, of domain knowledge, and bring that to the user at the right time so they can learn faster, understand the correct action, and take action to repair the asset. And so that's what we're going to talk about. In the past, some of these stall because it's really hard. You have a tough book, you have grease on your hands. It's hard to find, information when you're out in the field. But really, With a field service assistant powered by generative AI, you can augment this with this context awareness. And so that's what we're going to show today. It's going to use a number of different components across the Databricks platform. I'll highlight those across the stack. The biggest thing that is really the focus is the Mosaic AI agent framework. And that's, again, going to provide that enterprise traceability and governance to make sure that the fixes, the interpretation, the responses are trained on your proprietary data. It maintains in your proprietary hands, and you can govern that end to end. So there's no leakage of your information that you want to make sure is secure, and your personnel and your partners are able to take advantage of that through the appropriate service models. And so that's where we'll dive in today into the application. Before we get there, I want to step at the reference architecture of some of the core data sets that take to power this application. Of course, there's the product telemetry data. This is, IoT data. It's about, torque or humidity or methane or oxygen levels. It can be all sorts of different things, the vibration that you're able to sense in the environment, about the environment, the machinery itself, how the machine is performing. You'll have a technical manual. So this is maybe the engineering design. You want to understand the traceability if you have a large, maybe offshore drilling platform. You want to understand how where the valve shut-offs are. You want to know where things are, be able to reference that material quickly, spot it in the field, and take action. So we're going to walk through that. You'll have other internal wikis. A lot of times that domain knowledge is, again, learned through that trial and error, through experience. This may be captured through internal procedures that maybe aren't in the technical manuals yet, or they're in your maintenance system where they were in an engineering work order in the past. You want to be able to bring that context out and bring that into the resolution. And then any user actions. So you want to understand the feedback of, I opened the door, I turned off the machine, I opened the door, I repaired this part, and then, for the next 30 days, this was the intended result, right? It actually got back to full performance, or it took this long to go to full performance. Start to understand how the action that was taken by the user actually produces the intended effect that you're looking. So we bring in this raw data across the enterprise. It's in PDFs, it's in IoT, MQTT. You have all sorts of different Kafka queues. You're pulling it off. We're bringing this in. We're creating embeddings. We're cleaning up the data sets, and then we're populating a vector search and being able to. We'll talk a little bit about the vector search. Bring that vector search in, and then that's where the RAG model is able to call on this information from the data set and actually link to it, so you can look at the primary source. You know exactly where the recommendation is coming from in the chatbot. You're not guessing that it's it's a hallucination. You want to make sure you avoid that. We're using underneath the hood things in the ecosystem, LangChain, DBRX, Llama Index, some of these things to create the embeddings for the vector search. And then on the right-hand side, you can bring this application out as a mobile app, or it could be on a desktop app that you're using, again, on a Toughbook out in the field, or whatever sort of computing environment you have out in the field. And so then you're able to diagnose, troubleshoot, and repair. Of course, all of this is governed by Unity Catalog. You're governing all the data sources as well as the AI models themselves. So that's a huge part of the Databricks intelligence platform, is that end-to-end governance across all of your data and AI assets. So within this, one other data source that I want to call out, you also want to augment things with things that you may not have, you may not be collecting but are useful to this type of field service application. In the Databricks marketplace, we have a number of data providers, partners in here, one of which AccuWeather, right? It provides weather data, real-time weather data. If you're going out into the field in the southern US, right, we had a massive ice storm this week. There's going to be ice that's impacting these energy assets, factories down there. We want to understand, hey, should we actually fix this asset? Do we need to wait for the storm to, thaw out and then the weather to warm up? How do we need to go about it? You want to have that context of what's actually happening in the environment. You're going to want to know where geospatially things are across the environment. We have partners like Cardo provide location intelligence and spatial data. Then there's many, many more. So you can bring in these data sets and AI models from our partners to augment your first-party data that's within your enterprise. So we'll bring in weather data here. And then within the Mosaic AI agent framework that I called out, we're going to be focusing on a pattern called RAG, Retrieval Augmented Generation. And this is what is linking back to those primary source documents and making them available. Directly on our website here, there's a thing about from 4Direct. They were at our summit last year. They presented on this, but it's really this ability of vector search with Databricks Delta Live Tables, Unicatalog, to bring in their source data in real time, understand their customer engagement, their inventory, their performance metrics, all of those sorts of things. We're going to touch on inventory here for spare parts. These are key for RAG applications, is bringing in this real-time context for what you're trying to figure out in the day-to-day. There's a number of other things here on how the framework works. What I'll ask from you as we go through today, if you want to go deeper on the technical components, reach out to your account team from Databricks. They can help you go deeper on each one of these components. Today, I'm not going to go super deep on the technical side, but I will certainly provide you some leave-behinds on solution accelerators that you can import directly into your environment to get started and learn how to build this exact solution that I'm sharing today. So with that, let's dive in to the demo. So what you're seeing here is a Databricks app. And what a Databricks app is, you have the unified authentication and governance here. So I didn't show you it, but you can just, you'll log in through your identity provider. So you have that same access methods that you have, authentication methods you have for the rest of the Databricks platform. Nothing additional you need to do. This is wonderful for internal use of a field service. If you service your own assets within your enterprise, you don't have to create another outside application, figure out all the authentication. This is fully authenticated, just like all your other Databricks installation is secured. So I authenticated, I'm logged in here, logged in as I think our founder and CEO, Ali, and Ali is going to help us administer cool electric code here. We have on the application a couple things about, six turbines in this case. See that there's one required here. So 1 out of 6. We have, 5 out of 6 healthy, and we're understanding what our maybe committed to energy production is and where we're at today. So you can see here, this is back in December. It's pretty warm in Massachusetts. We'll see in a second here in December. But we had a decline in some of the real output. So we got to figure out what happened there. And then we can look, we have maps in here. I mentioned Cardo earlier, but there's our installations here are offshore off the coast of Nantucket in Massachusetts in the US. So in here, we can see where our turbines are located. And of course, they're going to be hard to reach out there, right? We want to be thoughtful about what equipment we're bringing with us, the weather conditions on the sea, and when we get in there, make sure that we have everything we need before we go out. So let's take a look at what's going on with this turbine. So we're gonna ask, how should I prioritize my day? I just woke up. Hey, okay, it tells us turbine A1234 here is offline. We're not meeting our expectations. We need to get this online as soon as possible. Hey, there might be also something going on with turbine C7892. We'll monitor that. Maybe we don't need to take an action right out. Right now, we need to figure out A1234. Let's mark it under maintenance. It's already offline. Let's mark it under maintenance and take action today. Make sure we get this back in service as soon as possible. So you can see here, we marked it under service in our ticketing service, ServiceNow, and we're going to be able to start working on it. So this is, if you think about behind the scenes, what's happening here is is an agent can say, okay, mark it under maintenance instead of your technician, your field service engineer having to try and fight the system, create all these custom UIs to be able to, put in, oh, it's this turbine, this date, here's the reason why. Your agent, your generative AI agent here in Databricks has all the context because it's pulling from those systems in real time and then is able to call an agent to take action, right? It's able to call the APIs for your maintenance system, file a ticket with all the right context. So it's going to improve your data quality of your maintenance system. It's not just going to be shorthand notes of like took machine offline, hope to bring it back by end of day, right? It's going to actually say, here was the sensor data up until now. Here's the contacts. I took it offline. Going to be able to figure out what's going on with it, and we'll add context to that ticket that got created today. So all of this is through the Mosaic AI agent. You can orchestrate that, and I'll show you exactly how we do that at the end of the presentation today. So we're going to continue this conversation. So we marked it for maintenance. Let's go poke into it and see what's going on there. This application, we're going to go in directly into the page. You get to design this entire application to your choosing, right? This is a web application framework. We support Dash and Streamlit, all the common kind of web frameworks that you and are familiar with. With R Shiny and similar as well. So we can see the critical error. It was automatically shut off. The equipment's kind of being smart, but we want to take action. We can see the current weather conditions, as I mentioned. I would love for it to be 30 degrees. It's a bit cold where I'm at today, but I would love for it to warm up a little bit. The wind speed here, we'll want to monitor that, right? We're going offshore. We want to make sure that it's not too high. Otherwise, it could pose a safety concern. And then there's humidity. So it's warning us, hey, it's high heat. Again, I'm getting up in the morning. I want to make sure I'm dressed for success here. I got to have my right equipment. Sometimes you don't know what you're going to face out in the field until you get there. Be a little bit more proactive. Make sure I have everything ready to go. How long has it been offline? When was it last serviced? Okay, what the next action needs to be. Current statistics about power generation, and then we can kind of see exactly when, what was going on with it, some of the environmental conditions that we know are kind of related to that asset performance. So let's take a look here. Let's go back into the chatbot. Again, we have the context. We still have the past week of operating things here. Let's analyze why the shutdown occurred. Looks like here we have the torque declined. Maybe there's something going on with the gearbox. Maybe it's not well lubricated. Maybe we need to add some oil there. We serviced it a little bit over a month ago. Again, we're back in December here. So we want to take this offline or it overheated. So we want to take it offline for lubrication. So we need to make sure we have oil to lubricate it. Let's find, we're in Massachusetts. Let's find, do we have oil in stock nearby? How are we thinking about orchestrating that supply chain to make sure we have appropriate spare parts, consumables nearby so we can bring that directly or we can pick that up on the way as we go out to service it. So here we are, great. We have 26, we have plenty of field. That's good. Our safety stock is in a great position. That's all well managed, also through data and AI, but we have it. We can just take care of our job here. So we're going to take a look here. Let's reserve an equipment so we can pick that up. So we're reserving it. Again, think of an agent calling this action, but I can just converse with it in natural language here. We're going to ask it if the weather conditions are safe. Yes, I can look at the actual reports here directly in the application, but let's actually confirm. Let's have that second opinion, make sure we're not missing anything. Okay, it tells us, yep, temperature is high. We want to make sure we're hydrated, but it is safe to operate. So that's great. And then let's go. Let's go to the site. Let's take a look at what is going on there. We're going to wear our sunscreen. We're going to have our PPE on, and we're going to make sure we take care of that. So we're going to get to the site, but it's out there. You're in the ocean. A lot of action going on. Hey, how do I actually perform this procedure. So it's going to go, it's going to tell me the procedure I have here. Like it's going to give nice instructions. It's going to talk about powering down the turbine and lockout, right? This is something that is very important. Whenever you're dealing with heavy machinery, there's hazardous energies, there's all sorts of different things. Whatever the safety regulatory things are. You want to make sure your agent is recommending that, your chatbot is telling exactly, make sure you're doing this type of procedure. So we have that exactly in here. It's grounded. We can trace that. We can understand that safety through the Mosaic AI framework. You can probe and understand, that it's calling out that safety procedure every time. It's going to tell us, here's the exact steps, access the gearbox, take a look at the levels, apply the oil, and move forward here. It's also going to give us a documentation here, exactly where it's pulling this procedure. So, here's a manual for one of these turbines. It's going to have exactly this. Make sure you comply with safety standards. Make sure, the wind turbine speed is make sure that it's braking, make sure the wind is less than 6 meters per second, right? Perform operations on a calm day. These are, make sure you have two people. All these very specific, it's going directly into the document. Again, you can operate this on your Toughbook, your industrial smartphone, where it's when you're dealing with gloves and things, you can actually talk to your phone and you can operationalize that device in the appropriate human factors way. So we have that documentation, we can refer to it. So if we need to refer to that, we have it right there, and then we can double check the instructions here. We're going to go ahead and perform the procedure. Say, we applied the oil and check that it all looks good, do a double verification here. Yes, all looks good. Let's do that. And okay, great. We completed the maintenance. This is complete. It's back online. We updated the ticket automatically with the context of the actions performed, and we are ready to go. Where our customer who's expecting that power is now much, much happier here. So let's email myself and my boss a summary here. Make sure that my boss knows we took care of it, we responded, and we met all of our service level agreements for that repair timeliness. So we have the full report. We can share that with our customer, exactly what happened if we need to send an RCA of what occurred and what we did to improve. And we're going to refresh the turbine data here and see that it's operational now and we're back at optimal levels. So that's one example of a workflow here that's end to end across this field service assistant, and this will apply across energy assets, semiconductor, aerospace, machinery, automotive, wherever you have equipment and machinery and needs maintenance, right? There's some required maintenance. You want to be proactive. In the case where you're reactive, you want to get smart quickly. You want to have that domain context brought to your operator so they can do the best job they have. You want to make sure you can call back into your enterprise systems for maintenance data, for ERP data, spare parts, all of that sort of thing to make sure you do the right job here.